Hello friends, welcome to our channel, Gajpal A Learning. In today's topic we are going to study about limit test for chloride, sulphate, iron, lead, heavy metal and arsenic. So let's start the video. First, limit test for chlorine. Purpose. The purpose of the limit test for chloride is to determine the presence of chloride ions, Cl- ion, in a pharmaceutical sample and ensure it does not exceed the specified limit. Method used in the limit test for chlorine is Mohs method, which uses a silver nitrate solution to precipitate chloride ions. Apparatus and reagents. Apparatus used: burette, for titration; conical flask, for mixing the sample with reagents; white porcelain dish, for preparing the sample; pipette, for transferring the sample; glass rod, for stirring; pH meter or pH paper, to check the pH of the solution. Reagents used: sample solution, the pharmaceutical sample to be tested; silver nitrate solution, AgNO3, a standardized solution for titration; potassium chromate indicator solution, a few drops; distilled water, for dilution and preparation of solutions. Procedure for performing limit test. Preparation of sample solution. For this, weigh an appropriate amount of the pharmaceutical sample. Dissolve the sample in distilled water to make a known volume solution, example, 100 ml. Ensure the sample is completely dissolved. If necessary, filter the solution to remove any insoluble impurities. Next is adjusting pH. Check the pH of the sample solution using a pH meter or pH paper. The pH should be between 4 and 7. If the pH is outside this range, adjust it by adding a small amount of dilute hydrochloric acid, HCl, or sodium hydroxide, NaOH, solution is needed. Stir and recheck the pH until it falls within the specified range. Titration. Add a few drops of potassium chromate indicator solution to the sample solution. This indicator forms a red-brown precipitate with silver ions. Using a burette, titrate the sample solution with the standardized silver nitrate, AgNO3, solution. Add the AgNO3 solution gradually with continuous stirring. The reaction between chloride ions, Cl- and silver nitrate, AgNO3, leads to the formation of a white precipitate of silver chloride, AgCl. Ag positive plus Cl negative to give AgCl precipitate. Continue adding the AgNO3 solution until the appearance of a faint but permanent reddish-brown color, silver chromate formation, in the solution. This color change indicates that all the chloride ions have reacted, and excess silver ions are now reacting with the chromate ions to form silver chromate. Next is endpoint determination. The endpoint is reached when the reddish-brown color persists, indicating that all the chloride ions have reacted. Record the volume of AgNO3 solution used, in milliliter, to reach the endpoint. Calculation. Calculate the percentage of chloride ions in the sample using the following formula. Percentage of Cl- equals V times N times 35.45 divided by W, where V is the volume of AgNO3 solution used, in milliliter, to reach the endpoint. N is the normality of the AgNO3 solution. 35.45 is the atomic weight of chlorine. W is the weight of the sample, in grams. Last is interpretation. Compare the calculated percentage of chloride ions with the specified limit. If the calculated value is less than or equal to the limit, the sample meets the requirements for chloride content. If it exceeds the limit, the sample is considered out of specification. Second is sulphate limit test. Purpose of test: to determine the presence of sulphate ions, SO4 2-, in a pharmaceutical sample and ensure it does not exceed the specified limit. Method of limit test: gravimetric method, which involves precipitation of sulphate ions as barium sulphate, BaSO4. Procedure for the test involve: preparation of sample solution. Weigh a known amount of the pharmaceutical sample. Dissolve the sample in distilled water to make a known volume solution, example, 100 ml. Ensure complete dissolution and filter if necessary. Next, precipitation of sulphate ions. Add a few drops of hydrochloric acid, HCl, to the sample solution to acidify it. Heat the solution gently, and then add a barium chloride, BaCl2, solution. A white precipitate of barium sulphate, BaSO4, forms. Bar2 positive plus SO4 2- to give BaSO4, precipitate. Next, filtration and washing. Filter the precipitate using a tarred filter paper. Wash the precipitate with hot water to remove any soluble impurities. Dry the filter paper and precipitate to a constant weight. Next, calculation. Calculate the percentage of sulfate ions in the sample using the following formula. Percentage of SO4 2 negative equals weight of BaSO4 divided by weight of sample into 100. Last step is interpretation. Compare the calculated percentage of sulfate ions with the specified limit. If it's less than or equal to the limit, the sample meets the requirements. If it exceeds the limit, the sample is considered out of specification. Third is ion limit test. Purpose. Purpose of the test is to determine the presence of ion, Fa, in a pharmaceutical sample and ensure it does not exceed the specified limit. Method used is thiocyanate method, which involves the formation of a red complex with ion ions. Procedure involves preparation of sample solution. Weigh a known amount of the pharmaceutical sample. Dissolve the sample in distilled water to make a known volume solution, example, 100 ml. Ensure complete dissolution and filter if necessary. Next is complex formation. Add hydrochloric acid, HCl, to the sample solution to acidify it. Add a few drops of potassium thiocyanate, KSCN, solution. The formation of a red complex, FaSCN, 2 positive, indicates the presence of ion. Next, titration. Titrate the sample solution with a standardized solution of potassium dichromate, K2Cr2O7, until the red color disappears. The reaction is as follows. 6FaSCN, 2 positive plus 14H positive plus Cr2O7 2 negative to give 6Fa 3 positive plus 2Cr3 positive plus 7SCN negative plus 7H2O. Next, calculation. Calculate the percentage of ion in the sample based on the volume and normality of the potassium dichromate solution used. Last step, interpretation. Compare the calculated percentage of ion with the specified limit. If it's within the limit, the sample is considered compliant. If it exceeds the limit, it's out of specification. Fourth is lead limit test. Purpose. To determine the presence of lead, Pb, in a pharmaceutical sample and ensure it does not exceed the specified limit. Method. Colorimetric method using ditizone as a complexing agent. Procedure used. Sample preparation. Weigh a known amount of the pharmaceutical sample. Dissolve the sample in a suitable solvent. Next is complex formation. Add ditizone solution to the sample solution. A pink or reddish-brown complex forms if lead is present. Then, extraction. Extract the colored complex into a suitable organic solvent, such as chloroform. Then, measurement. Measure the absorbance of the organic layer at a specific wavelength using a spectrophotometer. Compare the absorbance value with a calibration curve to determine the concentration of lead in the sample. Then next is interpretation. Compare the concentration of lead in the sample with the specified limit. If it's within the limit, the sample is considered compliant. If it exceeds the limit, it's out of specification. Fifth is heavy metals limit test. Purpose. To determine the presence of heavy metals, example, lead, mercury, cadmium, and others, in a pharmaceutical sample and ensure they do not exceed specified limits. Method used. By digestion followed by atomic absorption spectrophotometry or other appropriate instrumental methods. Procedure. The specific procedure for the heavy metals limit test can vary depending on the pharmacopoeia and the type of heavy metal being tested. It typically involves sample preparation. Under this, weigh a known amount of the pharmaceutical sample. Dissolve the sample in a suitable solvent. Next, acid digestion. Acidify the sample solution with concentrated acids, example, HCl, HNO3, to convert heavy metals to an analyzable form. Next, instrumental analysis. Under this, analyze the digested solution using atomic absorption spectrophotometry or other suitable instrumental methods. Last step involve interpretation. Compare the concentration of each heavy metal in the sample with the specified limits for each metal. Sixth is arsenic limit test. Purpose. To determine the presence of arsenic, as in a pharmaceutical sample and ensure it does not exceed the specified limit. Method used. Kutschite method, which involves the formation of arsine gas followed by its reaction with silver nitrate. Procedure. This involves sample preparation. Weigh a known amount of the pharmaceutical sample. Digest the sample using a mixture of concentrated hydrochloric acid, HCl, and concentrated sulfuric acid, H2SO4, to convert arsenic to arsine gas. Next is formation of arsine gas. React the digested sample with sodium borohydride, Nub4, to generate arsine gas, ASH3. Then, silver nitrate reaction. Pass the arsine gas through a silver nitrate, AgNO3, solution. Arsenic in the form of arsine reacts with silver ions to form a black precipitate of silver arsenide, Ag3As. Next is filtration and measurement. Filter and collect the black precipitate. And measure the weight of the precipitate. Next is calculation. Calculate the percentage of arsenic in the sample based on the weight of the precipitate. Last is interpretation. Compare the calculated percentage of arsenic in the sample with the specified limit. If the calculated value is less than or equal to the specified limit, the sample meets the requirements for arsenic content. If it exceeds the limit, the sample is considered out of specification. Thanks for watching our video. If you like the content, then please subscribe the channel. Thank you.